Welcome to Easy Driver, the most reliable source of automotive information on YouTube. Please like, share, comment and subscribe. In Part 1, we looked at how virtual reality is revolutionizing car design. Now, let's explore how VR is making car testing faster, safer, and more efficient. From crash simulations to performance testing, VR is helping automakers perfect their vehicles before they hit the road. Let's get started. Enhanced communication. By visualizing designs in 3D, team members can communicate more effectively. Instead of relying on abstract descriptions or 2D diagrams, they can point to specific components in the VR environment and explain their ideas visually. This reduces ambiguity and accelerates problem solving. An engineer explaining an issue with the suspension system can demonstrate the problem in VR, making it easier for designers to understand and address the issue. Customer involvement in design. Some automotive companies are experimenting with involving customers in the design process through VR. Potential buyers can explore and customize a car in a virtual showroom, providing feedback on features, colors, and layouts. This customer-centric approach ensures that final designs meet consumer expectations and preferences. Real-time feedback and decision-making. VR enables instant feedback loops, allowing teams to make decisions faster. Instead of waiting weeks for feedback on a prototype, teams can identify issues and implement changes in real time during VR design sessions. This leads to more agile workflows and shorter development cycles. Cost reduction in car design with VR. Eliminating physical prototypes. Building physical prototypes is expensive and time-consuming. Each prototype can cost hundreds of thousands of dollars, and multiple iterations may be required. VR eliminates the need for many of these physical models by providing a virtual alternative. Designers can test everything from aesthetics to functionality in VR before committing to a physical prototype, saving significant amounts of money. Reduced testing costs. Physical testing, such as crash tests, requires specialized facilities and expensive equipment. VR allows manufacturers to perform these tests in a virtual environment, simulating various scenarios without damaging real vehicles. This reduces the costs associated with physical testing and minimizes resource waste. Efficient resource allocation. By identifying and resolving issues early in the design process, VR reduces the need for costly rework. Resources can be allocated more efficiently, and development timelines can be shortened. This helps manufacturers stay within budget and deliver products faster. Virtual reality in car testing. Advanced safety testing. Safety is a top priority in the automotive industry, and VR offers new ways to test and improve vehicle safety. In a virtual environment, manufacturers can simulate a wide range of crash scenarios and analyze how the car and its safety features perform. Instead of crashing real vehicles, VR allows for virtual crash simulations. Engineers can study how different parts of the car absorb impact, how airbags deploy, and how seatbelts restrain passengers. These insights help improve vehicle safety designs before physical crash tests are conducted. VR can simulate emergency situations such as sudden braking, skidding on ice, or rollover accidents. By analyzing how the vehicle performs in these scenarios, manufacturers can refine safety systems and improve overall vehicle stability and control. Performance testing. VR provides a controlled environment to test vehicle performance under various conditions. This includes simulating driving on asphalt, gravel, mud, or snow. Different weather conditions like rain, snow, or extreme heat can also be simulated. Engineers can test the vehicle's handling on steep hills, sharp turns, and uneven roads. These tests help optimize the vehicle's handling, suspension, and powertrain for real-world conditions. Autonomous vehicle testing. The development of autonomous vehicles requires extensive testing to ensure safety and reliability. VR allows engineers to simulate thousands of driving scenarios, including unpredictable elements like pedestrians, cyclists, and other vehicles. This helps refine the AI algorithms that control autonomous vehicles, ensuring they can respond correctly to any situation. By testing in VR, manufacturers can accelerate the development of self-driving technology without risking real-world accidents. The future of virtual reality in car design and testing. Integration with artificial intelligence, AI. Future VR systems will likely integrate with AI to provide smarter design and testing processes. AI can analyze VR simulation data to suggest design improvements, optimize safety features, and enhance vehicle performance. Augmented reality, AR, for real-world integration. Combining VR with augmented reality, AR, will allow designers and engineers to overlay virtual models onto physical prototypes. This hybrid approach will provide even more flexibility and precision in the design process. Virtual reality for autonomous vehicle development. As self-driving technology advances, VR will play a crucial role in simulating complex driving scenarios. This will help ensure autonomous vehicles are safe and reliable under all conditions. Virtual reality is not just a tool for design and testing, it's a catalyst for innovation in the automotive industry. By improving efficiency, reducing costs, and enhancing collaboration, VR is helping manufacturers create better, safer, and more sustainable vehicles. As VR technology continues to evolve, its impact on car design and testing will only grow, shaping the future of the automotive world. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.